The idea that Boeing and Airbus would ever face a serious challenger outside the West once sounded unrealistic. For decades, wide-body aviation has been an exclusive club, guarded by massive budgets, advanced engines, and tightly controlled supply chains. But that confidence is starting to crack, quietly and with far less fanfare than you'd expect. China has moved a long-running project into a phase that signals something much bigger. The aircraft is called the C929, and recent developments suggest it's no longer a distant ambition. It's a warning shot. For years, China relied almost entirely on Western aircraft to fuel its exploding aviation market. That dependence came with costs, delays, and political pressure. Every major airline expansion meant negotiations with foreign manufacturers, foreign engines, and foreign certification bottlenecks. The launch of the C919 showed China could break into the narrow-body market. But wide-body aircraft are different. That's where true aerospace power is measured. Long-range jets aren't just harder to build. They require mastery over materials, engines, systems integration, and global standards. And that's exactly why the C929 exists. The project didn't begin as a solo effort. Back in 2015, when China's wide-body experience was still limited, the plan was to share the burden. A joint program was formed between COMAC and United Aircraft Corporation, originally named the CR929. On paper, it looked like a perfect match. China would handle manufacturing scale, financing, and supply chains. Russia would contribute its strengths in aerodynamics, materials, and engine know-how. The final assembly line would sit in China, while the aircraft would serve Asian and Eurasian markets first. But behind the scenes, the partnership was fragile. Reports later suggested disagreements over technology ownership, especially engines. Then geopolitics intervened. As tensions escalated in Eastern Europe, Russia's aerospace priorities shifted sharply toward defense. Engineers were reassigned. Deadlines slipped. Milestones went unmet. While Shanghai reportedly completed most of its assigned work, Moscow struggled to deliver. By 2022, Russia officially stepped away. The collaboration was over. At that moment, many assumed the project would quietly stall or disappear. Wide-body aircraft programs collapse all the time, even in the West. But instead of backing down, China made a bold decision. The aircraft was renamed C929, and development continued independently. Russia still supplies a limited number of components. But the core design, systems, and integration are now firmly in Chinese hands. Skepticism followed immediately. Western analysts questioned whether China could realistically meet international standards without foreign technical leadership. The doubts were loud, and they lasted for years. Then came the announcement that changed the tone of the conversation. In early 2025, COMAC revealed that the C929 had officially entered its flight testing phase, not as a prototype built for domestic certification, but as a wide-body aircraft designed to meet international standards with independent intellectual property rights. That detail mattered. It signaled intent beyond China's borders. Western media noticed, suddenly, the C929 wasn't framed as a symbolic project. It was framed as competition. The shift happened because the numbers didn't match the old assumptions. The C929 isn't a stretched narrow body or a regional compromise. It's a true long-range wide-body aircraft designed to carry around 280 passengers across distances of up to 12,000 kilometers. That puts it squarely in the same category as the most successful wide-body jets in service today. Routes like Beijing to New York or Shanghai to London are exactly what it's built for. Comparisons to the Boeing 787 Dreamliner and the Airbus A350 are no longer exaggerated. They're unavoidable. What really surprised experts was how quickly opinions shifted once the technical details became public. The aircraft uses a twin-aisle wide-body layout, not just for capacity, but for comfort and efficiency on ultra-long-haul flights. Its wingspan stretches close to 65 meters, surpassing even the 787, demanding extremely high aerodynamic precision. The cabin width reaches approximately 5.5 meters, slightly wider than both Western competitors, promising more space and flexibility for airlines and passengers alike. Materials tell an even more important story. Over half of the aircraft's structure uses carbon fiber composite materials, significantly reducing weight while improving fuel efficiency and durability. Titanium alloys account for roughly 15% of the structure. Matching the most advanced wide-body designs currently flying, this isn't cosmetic progress. These materials are difficult to manufacture, difficult to certify, and impossible to fake at scale. They represent real industrial capability. The system's integration is equally ambitious. The C929 reportedly includes more than 2.2 million individual components and over 3,500 completed test sets. 10 core systems, including avionics, navigation, hydraulics, and advanced wing systems, have been developed to work together under a real-time monitoring architecture. This allows continuous tracking of aircraft performance throughout flight, something many existing aircraft models still lack in fully integrated form. 4 of the 9 avionics suppliers involved are domestic, signaling a quiet but important shift in China's technological independence. But no part of the aircraft carries more strategic weight than the engine. Engines are the last fortress of aviation dominance. For years, China relied on Western power plants, leaving its aircraft vulnerable to export controls and political pressure. The C929 changes that equation with the introduction of the CJ2000 engine, initially developed alongside earlier programs but held back due to certification concerns. The CJ2000 is now positioned as the long-term heart of China's wide-body ambitions. Reports claim the engine delivers up to 35 tons of thrust, placing it firmly in the same class as the most advanced engines used by Western wide-body aircraft. Its fan diameter and overall size exceed some existing competitors. While cruise fuel consumption is said to be lower than many international counterparts, noise reduction, smoother operation, and improved passenger comfort are all part of the design goals. Test flights are scheduled for later in the decade, and while certification remains a challenge, success would mark a historic breakthrough. It would mean full control over propulsion, the single most sensitive component in commercial aviation. Pricing adds another layer of pressure. China has a long history of entering global markets with competitive cost structures, and aviation appears no different. While official prices haven't been disclosed, industry observers expect the C929 to undercut comparable Western aircraft. For airlines operating on thin margins, especially in emerging markets, that difference could be decisive. It's not just about buying cheaper aircraft. It's about diversifying suppliers and reducing exposure to political risk. The broader strategy is becoming clearer. The regional ARJ21 has been rebranded as the C929, signaling consolidation of China's domestic civil aviation ecosystem. Beyond the C929, there's growing buzz around larger future aircraft like the C939 and even the speculative C949. Some reports suggest early design work has already begun. The most ambitious claims involve a supersonic wide-body aircraft targeted for a timeline that sounds distant but mirrors how long today's wide-body programs took to mature. All of this is driven by scale. China is already the world's second-largest economy, with one of the fastest-growing aviation markets on the planet. Forecasts suggest the country will need thousands of new aircraft over the next 2 decades, including around 1,000 wide-body jets. Relying exclusively on Boeing and Airbus would be enormously expensive and strategically limiting. Building an independent aviation industry isn't optional anymore. It's inevitable, of course. Challenges remain. Certification, global trust, after-sales, support, and long-term reliability can't be rushed. Every aircraft program faces setbacks, and the C929 will be no exception. But momentum matters. With the C919 already in service, the C929 entering flight testing, and future projects quietly advancing, China is building something comprehensive, not experimental. If the C929 successfully completes testing and enters commercial service, it won't just add another aircraft to the market. It will force a recalculation. For the first time in decades, Boeing and Airbus may have to contend with a third power capable of competing across the full spectrum of commercial aviation. And that raises a question the industry hasn't seriously asked before. Is the era of Western dominance in wide-body aviation nearing its end, or is this just the beginning of a much longer race? What makes this moment especially uncomfortable for the West is that the C929 doesn't exist in isolation. It's part of a much larger pattern that's been quietly forming over the past decade. China isn't experimenting anymore. It's building layers, Manufacturing capacity, certification experience, supply chains, training pipelines, and long-term maintenance networks are all being developed in parallel. That's how aerospace dominance is actually achieved, not through one aircraft, but through an ecosystem that can sustain generations of them. One reason Western manufacturers are paying close attention is timing. Boeing and Airbus are both dealing with internal pressure. Production bottlenecks, certification scrutiny, and rising costs have slowed delivery schedules. Airlines are frustrated. Leasing companies are watching margins tighten. And while neither manufacturer is in danger,